Okay, Assalamualaikum warahmatullahi wabarakatuh, and hi guys. So for today we're gonna learn about Cramer's rule. Okay, so we're gonna learn about Cramer's rule for 2 by 2 and also 3 by 3. Okay, as for the start, I remember Cramer's rule is all about on how to find the determinant. Let's say if you already good in finding the determinant, then you will not have any problem in solving linear system by using Cramer's rule. So, first, let's take a look on Cramer's rule for 2 by 2 matrices. Okay, let's say if we have 2 by 2 matrices, okay, and they give to you a linear system which is equal to A11 x1 plus A12 x2 equal to B1 and A21 x1 plus A22 x2 equal to B2. Okay, from here, okay, we need to form AX equal to B. So the metric form. Okay, so what we need to find is first we need to separate this linear system into matrix A and matrix B and also matrix X. Okay, so first step, matrix A is equal to, okay, we form AX equal to B. So matrix A is equal to A11, A12, A21, A22. And then matrix X is equal to X1, X2. And then matrix B is equal to B1 and B2. Next, we need to find the determinant of matrix A and also determinant of the coefficient for matrix when we modify the coefficient of matrix A. Okay, so find determinant of matrix A. So it would be, let's say if we denoted matrix A as D, determinant of matrix A as D, so A11, A12, A21, A22, okay, is equal to the determinant as we know, this one multiply, then minus with this one multiply with the element. Okay, so it would be A11, A22 minus A12, A21. Okay, so this is the determinant of matrix A. Then find the determinant of the x1. Find determinant of the x1 and the x2. Okay, x1. So how are we going to find determinant of the x1? Okay, determinant of the x1 means that, okay, you need to substitute the value of matrix B into matrix A. Okay, let's say if we want to find x1, remember this one, this column, the first column represent x1. Second column represent x2. So since right now we want to find the determinant of x1, so we need to substitute matrix B, which is B1 and B2 into the first column. Okay, so how about the second column? So the second column is still the same element. Okay, then find the determinant between this matrix. So it would be B1 A22 minus B2 A12. Okay, next one, determinant of x2. So since right now we want to find determinant for x2, so we need to substitute the value of B, matrix B into this one. Okay, second column. So A11, A12, the second column will be replaced with matrix B, B1 and B2. So we will find the determinant of these matrices A11, B2 minus with B1, A12. Okay. After we got these three determinants, first one is determinant of matrix A, determinant of Tx1, determinant of Tx2, then we will find the value of x1 and x2. How? X1 and x2. How? Okay, so to find this value, the coefficient, the value of unknown variable, which is x1 and x2, x1 is equal to dx1 over d. So, if this one, if we want to find x1 is equal to dx1 over d, so for x2 it will be dx2 over d. Then you will get the determinant of then you will get the value of x1 and also x2. Okay, next we will take a look on how to find the determinant for the Cramer's rule, to solve Cramer's rule for 3 by 3 matrices. Okay, remember, let's say if you calculate your determinant and you get determinant is equal to 0, then we cannot apply the Cramer's rule. Why? Because when determinant is equal to 0, it means that there is no unique solution or unique solution does not exist, or there is no solution. In other words, there is no solution. Okay? So, it's important that you need to make sure that determinant must be not equal to 0 for this Cramer's rule to be applied. Okay? Okay, so we're going to take a look on Cramer's rule for 3 by 3 system. Okay, say we have 3 by 3 systems. Okay, so if we give to you a linear equation, a11 x1 plus a12 x2 plus a13 x3 equal to b1, a21 x1 plus a22 x2 plus a23 x3 equal to b2, and then a31 x1 plus a32 x2 plus a33 x3, which is equal to b3. Okay, so from here you can separate it into matrix of coefficient matrix A11, A1, A21, A31, A12, A22, A32, and then we have A13, A23, A33, and then we also have matrix X, which is equal to X1, X2, X3, and then the matrix B, which is equal to B1, B2, B3. Remember, for Cramer's rule, it's all about on how to find the determinant. So, first we need to find the determinant of matrix A. Okay, determinant of matrix A. So it would be matrix D is equal to A11, A21, A31, A12, A22, A32, A13, A23, A33. Okay. To find this determinant, you can use either third order determinant. Remember on how to find the third order determinant, or you can use higher order determinant. Okay. Higher order determinant. Higher order determinant. So maybe I will write down this one to make you remember back what is third order determinant, like this. Remember this one multiply with this one, this one, this one, this one. So it will be A11, A22, A33 plus V A12, this one, A12, A23, A31 plus V A13 times V A21, A32, A21, A32, and then minus V this side, the left side, which is A13, A22 multiplied with A31 plus V A23, A32, A11 plus V 1, A33, A12, A21. Okay, and then you will get the determinant. Or you also can use the higher order determinant. One I told you before, which is higher order determinant. For example, let's say if I want to expand around the first row. So, determinant of matrix A will be equal to A11 C11 plus V A12 C12 plus V A13 C13. After you find the determinant of A, as usual, we need to find determinant for the x1, the x2, and also the x3. Okay, so for the x1, it will be, okay, since right now we want to find determinant for x1, and remember, this one will be x1. This one will be x2 and this one will be x3. So we need to substitute this value of matrix B into which variable we want to find. For example, right now we want to find for x1. So we substitute in the first column for x1. So it will be right now, okay, B1, B2, B3. So A12, A22, A32, A13, A23, A33. So this is for the x1. And as for the x2, it will be, okay, since right now we want to find for x2, so we will substitute the second column. Okay. So first one is same, A11, A12, A21. Second row, first column, and A31. And then for this one, it will be B1, B2, B3. And then this one will be A1, 1, 3, A2, 3, and A3, 3. Okay, this one is for the x2. And how about the x3? So it will be, x3 will be, okay, the first one is still the same because right now we want to find for x3, so we need to substitute B, matrix B into the third column. So for the first column is similar to the original one, A1. Sorry, once again I put A12 is supposed to be A21. A31, A2, A12, okay, A22, A32, and then this one will be B1, B2, and B3. Okay, after you find the determinant for these three, then to find the value of x1, x2, and x3, it will be okay. So x1 is equal to dx1 over d. x2 will be equal to, why I write down as 3 is supposed to be, x2 is equal to dx2 over d, and x3 will be equal to dx3 over d. Then you will catch your value of x1, x2, and x3. Okay, so next one, we're going to take a look on the example of Cramer's rule, okay, on how to solve linear system by using Cramer's rule. Okay, so right now let's solve the linear system by using the Cramer's rule method. Okay, so we have right now 8y plus with 6z equal to negative 4. It was a linear equation, and then the second one is negative 2x plus with 4y minus 6z equal to 80, and then x plus y minus z equal to 2. Okay, so from here, okay, form the matrix of ax equal to b. So we have, okay, since right now we didn't have x at here, right? So we assume that for x it will be 0. 0x plus with 8y. 0x plus 8y. So for the coefficient matrix, A will be 0, and then 8, and then 6. And this one, negative 2, 1, 4, 1, negative 6, negative 1. Okay. And then for matrix X, it will be, since the variable for here it gives you y, z, x, y, z. So this one it will be x, y, z. And then for matrix B, it will be, remember this at your right side, negative 4, 80, and 2. Okay. So for the first step, we need to find the determinant of matrix A. So to find the determinant of matrix A, D is equal to 0, negative 2, 1, 8, 4, 1, 6, negative 6, negative 1. So I will use the order determinant to find the determinant of matrix A. Okay, so 0 times with 4 times with negative 1. So 0 times with 4 times with negative 1 plus with, okay, this one, 8 times with negative 6 times with 1. Then plus with this 6 times with negative 2 times with 1. Okay, this one. And then the other side, which is here, so 6 times with 4 times 1. Okay, so minus with 6 times with 4 times with 1 plus v, okay, negative 6 times with 1 times with 0, and also negative 1 times with 8 times with 2, negative 2. So we write down one by one. Okay, negative 6 times with 1 times with 0 plus with negative 1 times with 8 times with negative 2. Okay, and then try to solve it. Remember, just use your calculator. 0 times 4 times negative 1, 0. 8 times negative 6 times with 1, get negative 48. Then 6 times with negative 2 times with 1, so you get negative 12. Minus with 6 times 4 times 1, 24. Negative 1, negative 6 times with 1 times with 0, this one you get 0. And then this one, negative 1 times with 8 times with negative 2, so you get 16. Okay, negative 48 minus with 12, you get what? So 60. Okay, 24 plus with 60, so you get 40. So negative 100. Okay. And after that, we need to find the determinant of dx1 is equal to, okay, remember for dx1, since we want to find for x1, means that you need to substitute the value of this matrix P into the first column. Oh my god, this one. Okay, into this one, x1, our x, or for this case is our x, y, and also z. Okay, so negative 4, 18, 2, 8, 4, 1, 6, negative 6, negative 1. So try to solve it by using I want to use third order determinant. So it will be negative 4 times with 4 times with negative 1 plus with this. Okay, this and this. 8 times with negative 6 times with 2 plus with 6 times with 6 times with 18 is 1. Okay, minus with then we have this also. This side. Okay, this to this and this to this. Okay, so it will be 6 times with 4 times with 2 plus negative 6 times with 1 times with negative 4 plus with negative 1 times with 8 times with 80. Okay, then just use your calculator. Negative 4 times 4 times with negative 1, it will be 60 plus 3, oh, since we have negative at here, so it should be negative. So 8 times with negative 6, 48. So 48 times with 2, okay, 96. 6 times 18 is 16. Sorry, 6 times with 18. So 108 minus with 6 times with 4, 24 times with 2, 48 minus positive 24 and then 8 times with or multiply with 8 negative 144. So you get for this one 16 minus with 96 plus 108, 28 minus with 48 plus 24 minus 144, so negative 72. So 28 plus with 72 this one is for dx1. So you need to find for dx2. Okay. For dx2, be equal to same 0, negative 2, 1, then substitute negative 4, 18 here. So I change the color. And then 6, negative 6, negative 1, and as usual. From here, we know that 0 multiplied with any value, so you get 0. And then this one, negative 4 times negative 6 times with 1 plus with 6 times with negative 2 to minus with, remember, this here to here and here to here, and for the left side here 6 times with 18 times with 1, negative 6 times with 2 times with 0, of course we get 0, negative 1 multiplied with negative 4 and negative 2. Okay, so we just write down 6, 18, 1 plus negative 6, 2 and 0, and plus with negative 1, negative 4, negative 2. I'm sorry about my handwriting, it's very bad. Okay, just solve this one. 0 times with 18 times with 1, negative 1, 0. This one will be 24. And then this one will be 6 times with negative 2, negative 12, negative 12 with 2. So you get 24. And then minus with 6 times with 18, 6, 108. Oh, this one, negative 6 multiplied with 2 multiplied with 0, 0. And then this one, negative 1 multiplied with negative 4 or times with negative 2. So you get negative 8. And then try to solve this one. Okay, as we know, 24 minus 24, you get 0. 108 minus with 8, so you get 100. Since we have negative at here, so it will be negative 100. And then the next one, we need to find for dx3, which is equal to 0, negative 2, 1, 8, 4, 1. Remember to substitute the value of matrix B into the third column. So it will be negative 4, 18, and 2. So try to solve this one. Okay, 0, 4, 2 plus with 8, 81 plus with negative 4, negative 2 and 1, and then minus with, remember, okay, now this side, okay, negative 4, 4, 1 plus 80 times with 1 times with 0 plus 2, 8 and negative 2. Okay, this one it will be 0 multiplied with 4, 2, of course it will be 0, and then plus with 8, 144, then negative 4 times with negative 2 will be 8. Okay, minus with this one, negative 4 times 4, negative 16, plus with this one, 18 times with 1 times with 0, 0, and then this one, it will be 2 times with 8 times with negative 2, 4 times with 8, negative 32. Okay, then 144 plus with minus b 32 negative 48, and just by using your calculator, 152 plus with 48, it will be 200. Okay, this one you already get the value for dx1, dx2 and dx3. So for the next step, we need to find the value of x1, x2 and also x3. Remember x1, oh sorry, for this case, since right now we use x, y and z, so it will be x, y and z. Okay, so for x, it will be dx over d. So determinant of x 100 over negative 100. Of course we get negative 1. And for y, be equal to dy over d, which is negative 100 over negative 100. So you get 1. And for z, be equal to 200 over negative 100. So it will be negative 2. Okay, so this is the value of the unknown variable, which is x will be equal to negative 1, y will be equal to 1, and z will be equal to negative 2. And we finish. Oh, remember, if you want to check if your answer is correct or not, you just can substitute inside the formula, which is exactly the same linear system. So do always try to check your answer if it's correct or not. Okay, as we know, the first one, the value of x is equal to negative 1. So we use the second rule or the second linear equation to x times with negative 1 plus with 4, 1 minus 6, negative 2. Okay, calculate it. 2 plus 4 plus 12. So 2 plus 4, 6. 6 plus 12 equal to 80. So your answer is correct. You also can do the third row, which is negative 1 plus 1 minus 2. So this one 0, 2. So your answer for this one is correct. Okay, so that's all. Thank you.